Okay, so I'm going over 2.5, which is applications involving percents. And this is the most applicable thing that we're learning this week other than just generally solving, because a lot of things in the world involve percents. And the way that the book explains how to do it is different than the way that I explain. I think the way that I explain it is better, which is why I teach it this way. So I wanted to make sure you guys had an alternate method beyond what the book does. So I'm going to just start out with some definitions here. So we've got the word percent, which splits up as per cent. And cent, well, if we have pennies, they are called cents, and they're 100 pennies in a dollar. So cent literally means 100. That comes from the Latin word centum, which means 100. So century is 100 years. Centurions were actually a group of 100 fighters or whatever. So it all comes from the Latin. So percent is basically something per 100 or out of 100 essentially. So per basically means division here. So whatever your percent is, you're dividing it by 100 to get the decimal form. So the basic percent equation is the amount equals the percent times the base. That is the formula that is in the book. And so the amount is what you have after you take the percent of it. The percent in this case must be written as a decimal, so you have to convert the percent to a decimal by dividing by 100. And then the base is kind of what you're starting with. I have an alternate form where we write it as a proportion. And so a proportion is where you have two equations equal to each other, and to solve you cross multiply, which means multiplying the diagonals. And I like this method because you don't have to worry about converting your percent to a decimal. It's part of the equation. And I think it's a little more versatile depending on what your situation is. And so we're basically just taking the definition of a percent, which is basically you have the percent out of 100, which is some part of something out of the whole. That's basically the definition. You're setting them equal to each other. And so that's the form that I'm going to be using throughout this whole presentation, because I think that's easier to understand than the equation that the book gives you. So I'm going to demonstrate there are basically three different ways that these types of problems can be worded. And so I'm going to go through all three different ways and then have a fourth bonus practice problem basically. So I've got two examples here. One is 338 is what percent of 520? And then the second one is what is 9.5% of 616? So when you're translating these, the percent part, that's simple. The question is, what is the part and what is the whole? The is, whatever goes with the is usually the part, and then the of is the whole, basically. So if you have something translated like this, the is the part, the of is the whole. And then that allows you to just basically plug in your numbers and then you start solving. So this first example, I have 338 is. So that means the 338 is on top where the part goes, because that has the word is with it. Now it says what percent. What percent means we don't know the percent. So that's going to be our variable. So that will be x. So whatever you're looking for, that's going to be x. The percent is always under 100. And then that means the 520, which goes with the of, because it says of 520, that is always in the denominator. So using this form, it's really easy to translate and figure out where everything goes, because the is always goes on the top, and then what goes with the of always goes in the bottom, and then the percent always goes where it's labeled percent. So it's really hard to mess up the setup if you use a proportion like this. So to solve this, we have to multiply our diagonals. So it doesn't matter which diagonal you start with. You can do either one, but let's say I want to do 338 times 100 to do that diagonal first. So I'm going to just write that out. 338 times 100. Then you multiply your other diagonal, the 520 times x. So that's 520x. So you take each diagonal, multiply them together, and then you set them equal to each other. So that's what the cross multiplication step is. And now we have an equation that we can solve. So first I need to do 338 times 100. And that is basically just adding 2 zeros to my number. So I have 33,800 equals 520x. And then we need to divide both sides by 520 because we want to get x by itself. So we need to get rid of that 520. So with percents, we usually allow decimals. We don't worry about making them fractions, so you can just hit the division button on your calculator. And this actually comes out to a whole number. We get 65 equals x. So x is our percent, so that means that this is 65%. So we don't have to do any converting from a decimal form to a percent or from a percent to a decimal if you use this form of the equation. It kind of takes care of all of that for you. So there's fewer places for you to mess up. Are there any questions on that example? Okay. So the next one says, what is 9.5% of 616? So we're going to set up our proportion, and I always have 100 in the denominator. They give us the percent, so I can fill that into the percent spot. So the percent is always over 100, so that's going to be 9.5 over 100. And then they give us of, so that of means 616, whoops, is in the denominator, because of is always in the denominator. And that means our unknown is on top, because it said what is. The is on top, and we don't know what that is. What the is. So we just have to figure out okay, 616 must go in the bottom, and then you have your proportion set up. So then you multiply your diagonals. So if I do the first diagonal, that would be x times 100, which I can just write as 100x. And then the second diagonal is 616 times 9.5. So you're multiplying your diagonals together. That's why it's called cross multiplication, because you're basically forming a cross or an X. So I need to multiply 616 times 9.5. So I get 100x equals, this comes out to 5,852. Then we need to divide both sides by 100 because I want just the x. So when I divide by 100, that gives me 58.52. So it's totally fine to write it as a decimal when we're dealing with percents. Rarely do we write percents with fractions. They're mostly decimals. Any questions on this example?
I got a question, because normally I take 338 and I'll divide that by 520, which gives me that decimal percentage, and then I just I just know what the percentage is. I've just dealt with that way, not this long way, but I guess this is a really good way to learn so you don't forget things, but does it matter if you do it the other way just to be quick?
No. So if you do that for the first example, that works completely fine.
Right.
Because that you're essentially doing the same thing as what we did. The problem is I see a lot of people that struggle with percents try to do that same thing in the wrong situation, where they start doing the wrong numbers in the wrong order. And so that's why I like to show it this way, because then you're always getting the right answer, just
Right.
regardless. But that works really well, especially if you're understanding what the question is asking for.
Okay.
Because sometimes you can get percents where they're over 100%, where the big number is on top. And that's usually where people mess up, because they always think that the small number has to be on top, but that's not the case.
No. Okay.
Are there any other questions? Okay. All right, so I'm still using the same equation where the is on top and the of on the bottom. And so the first one here on the left is the third possible way that these could be worded. 126 is 15% of what number? And this is one that people are prone to possibly doing incorrectly. So I need to set up my proportion, and I always have 100 in the denominator, and then I'm given a percent, so that goes over the 100. In this case, they're giving us the is, so they have 126 on top, which means we need to find the denominator, the of portion. So when I cross multiply, I have 126 times 100. And then in the other diagonal, I have x times 15. So now I need to do 126 times 100. So anytime you multiply by 100, that just adds 2 extra zeros. And then I'm solving for x, so I need to divide both sides by 15. So when I put that in my calculator, that gives me 840 equals x. So in this case, 126 is 15% of 840. The most common error I see for something like this is that people multiply 126 by 0.15, but that gets you a smaller number. We're looking for a larger number because we're looking for the of part, the bottom. And if it's 15%, that means it's smaller than what you started with, so your number is going to be bigger. So if you set up your proportion, it's really hard to make a mistake, because then you're just following what's the if, what is the of, where's the percent going, and it's just kind of plugging things in and then solving. The second one here is 576 is what percent of 800? So I'll show this with the way that Tina was doing. So this is like the first one that we did. So you could take 576 and divide it by 100 or 800, and then multiply it by 100 to get the percent. And so that would give you 72%. This works because if we set it up with the proportion, I would have 576 over 100 equals my percent over 100. And essentially what you're doing is you're just multiplying both sides by 100 so that you have x by itself on the right side. And so that's why this works. This is why you're allowed to do this way, is because it's the same formula. We're just basically skipping a step. And instead of doing the cross multiplication, we are multiplying both sides by 100 and then just using our calculators to get the math. Are there any questions? Okay, so moving on to actual word problems, and this is where this stuff shows up in real life. So if you're doing anything with sales tax, discounts, markups, tips, a lot of things that involve money, if you are adding a percent to something, so with tax you're adding things on. If you're selling something and you're marking up the price, you're adding on to it. If you have a bill at a restaurant, you're adding in tip. Anything that you're adding, you can modify the equation that I'm using here so that you have the new price on top, the old price or the original price on the bottom. You still have it over 100, but what happens is instead of just being percent, it's 100 plus the percent because you're adding in the percent to the existing price. And the existing price is considered 100% of the price, basically. You're paying 100% of your bill plus a percent. So that's why we have 100 plus percent. If you're subtracting something, like if you have a discount, then you have your 100% of the bill, but then you're taking away something, so you're subtracting that percent out. So the difference is that that equation has 100 minus percent on top instead of 100 plus the percent. The way the book tells you to do the sales tax, discounts, markups, all that thing is it actually has separate equations, and you don't really need to do that. You can use the same proportion, and we just have to make a small modification, and then it works the same way, and you don't have to remember multiple different equations. So I've got many examples. I think I have like 4 examples here of these types of problems. So a drill is on sale for $99.99. If the sales tax rate is 9%, how much will Molly have to pay for the drill? So here we are adding on to the existing price because tax is making it more expensive. So we have the new price over the old price, and then we have 100 plus the tax over 100. So let's see. So we don't know what the original price is. It doesn't really matter here. Or the original, we're going to consider the $99.99 as the original price. Let's start. That's the starting price. So really, instead of new and old, so let's call this the starting price. New price still works. So this is starting at $99.99. And then I have it over 100. We're adding 9%, so this is going to be 100 plus 9 in the top. So now we want to know what is the new price after we add in tax. So our starting price, what the original price is $99.99. We're adding tax, and now there's going to be a new price, the new total, essentially. So I can simplify the second fraction here so that I have 109 over 100. So I have x over 99.99 equals 109 over 100. So now we're going to cross multiply. So I have x times 100, which gives me 100x. And then I multiply the other diagonal. So this is 99.99 times 109. So I'm going to do that on my calculator. That gives me a large number here. So that's 10,898.91. And then we divide both sides by 100. And so that essentially moves the decimal point to the left twice. And because this is in dollars, we're going to round it to 2 decimal places because this is in money. So this is going to give us 108.99 when you round it to 2 decimal places because you get 0.98991. So that is using the formula that we are that I'm giving here, where you're setting up a fraction, you have a proportion, you plug in the numbers, you cross multiply and solve. For a situation like this, the alternate method is to multiply by 1.09 because you're adding in 9% tax. That will get you the same answer.
Yeah, I use that a lot.
Yes. Yeah, that is what I do that too in these types of situations. You get the same exact number. You just remember that you start at 1 and then you're adding in whatever the percent is and you have to convert it to a decimal. So you get the same answer either way. One is basically using algebra. The other way is using arithmetic, basically. So it's basically which method you prefer. There are some situations where it's better to use it the long way that I'm showing here. Are there any questions? Okay. Here's a little more complicated example. Rick purchased 4 new tires that were regularly priced at $94.99 each, but are on sale for $20 off per tire. If the sales tax rate is 6%, how much will be charged to Patrick's Visa card? So this is it's a multi-step process because we have to figure out how much the tire is after the discount, the $20 off. Then we have 4 of them, so we need to multiply that by 4. Then we need to add in the sales tax. So starting with price of a tire is $94.99, and then there's $20 off. So that gives us $74.99. So that means if we have 4 tires, that is 4 times $74.99. So that comes to $299.96. So now we're adding 6% tax to that total price. So I'm going to set this up with the proportion method, but if you want to do it without the proportion method, you just need to multiply by 1.06 times 299.96. So 6% is 0.06, so you just add a 1 in front and then you can multiply that. But the proportion method would mean, okay, we don't know what our new price is after tax, but we know the starting price is $299.96. Then we have 100 plus 6%, and then it's over 100. So I have x over 299.96 equals 106 over 100. So when I multiply by diagonals, I get 100x equals 299.96 times 106. So of course I have to do this on a calculator. It's very rare that I do anything with percents without a calculator, because that is something that doesn't really, unless you get really lucky with your numbers, most of the time you need a calculator. So that gave me $31,795.76, and then we divide that by 100, and then we get x equals, and I have to round to 2 decimal places since money has 2 decimal places. That's $317.96 because that 7 after the 5 rounds it up to a 6. And you would get the same answer much quicker if you just did 1.06 times 299.96. Are there any questions? Okay. So now here's a kind of a a two-parter here. A hands-free kit for a car costs $62. An electronics store has it on sale for 12% off with free installation. What is the sale price on the hands-free kit and what is the discount? So here it's important to understand the difference in the language. The discount refers to how much money you're saving. The sale price is the price after that discount is removed. So because now we have a discount situation, this would be where you would have your new price, and then I'll call this the starting price again. And in this case, you're subtracting from 100 instead of adding because you're going to have a cheaper item. You're taking away from the price to make it smaller. So now it's 100 minus percent. So our starting price is $62. And we want to know what is going to be the sale price, the new price, once we take off that discount. So that's going to be our unknown. That's going to be X on top. And then we have 100. And then on the numerator, we have 100 minus 12. So a lot of people mess up the discount situations because depending on how it's worded, sometimes people subtract the wrong number. So you're subtracting 12%. So instead of paying 100%, you're now paying 88% of the original price. So when you simplify that, you have X over 62 equals 88 over 100. So now we can cross multiply. So if I multiply, I get X times 100, or 100X, equals 62 times 88. So 100X equals, and then I need to do 62 times 88. It gives me 5,456. And you divide both sides by 100. You get X equals 54.56. So that is the sales price. The discount is the difference between the original price and the sales price, the 54.56. An easy way to find the discount is to basically take 12% of what you're starting with, and instead of, so when we had tax, we did 1 point whatever, we added on. Here we just want to know how much was removed or how much was subtracted. So we want to know what 12% of the 62 is. So that gives you $7.44. So that is the discount. You saved yourself almost $7.50. And if you do 62 minus 54.56, you get the same exact number. So the alternate way is to figure out the discount first, figure out what 12% of 62 is, and then subtract that from 62 to get the sales price. So you can do it either way. If you don't like the proportion method, you can still find the sales price by using 0.88 times 62. Because then you're subtracting off the 12%, and that will give you your sales price without having to first figure out the discount. So much like with a tip, where you can do 1 plus the amount and then multiply it by your bill, you can discount by doing 1 minus that and then multiply it by the bill, and you'll get the same answer. Are there any questions? Okay, now this is the type of problem that most people get wrong. Because I've seen this, I've taught percents for years, and when you're trying to find what the original price was after the discount, people always mess that up. And that's the people who tend to mess it up are those that tend to use the decimal method where they just multiply their price by the decimal and then figure it out from there. But if you use the proportion method, then people don't mess it up. So this is one of the reasons why I teach it with the proportions, because then you are unlikely to mess this type of problem up. So a Blu-ray disc is on sale for $18. If this represents an 18% discount rate, what was the original price? So any type of problem where they give you the sale price and the percent and you're trying to work backwards to the original, those are the ones where people tend to mess up, and that's where the proportion method is best. So I set up my proportion. I'm going to have it over 100. It's an 18% discount, so that's going to be 100 minus 18 for the top as that percent. So we're having the sale price. It says the is on sale for 18%. That is the new price. That's on top. So we're looking for the original price. So our setup is 18 over x equals 100 minus 18. And the only reason these are both 18 is because one's $18, one's 18%. I should have changed it to like 20% or whatever so you can see which number goes where. I can actually highlight those. So this 18 is the price. And then this 18 is the percent. So that way you can keep track of those. So 100 minus 18, I need to simplify the top of that fraction. So I have 18 over x equals 82 over 100. So now I'm going to multiply my diagonals. 18 times 100 is one diagonal, and then x times 82. So 18 times 100 is 1800 equals 82x. And so now we're going to divide both sides by 82 because I just want x. And I'm going to round this to 2 decimal places because this is a price. So it's 21.95 equals x. And so the original price was $21.95. Now I'm going to show you what people do wrong because this does not work. I see a lot of people say, okay, I'm going to take 18% of $18. And they get $3.24. And then they take that $18 and they add the $3.24 back in. And they get $21.24. And they're like, oh, okay, it's close enough. No. If you had larger numbers, you'd be much farther off. You can't find the percent and add that back in because the percent is operating off of the number you started with. 18% of 21.95 is larger than 18% of 18. So you can't take 18% of 18 and add it back in because you're not adding in the same amount. It's not a linear relationship where the amount you subtract is the same you add. It depends on where you're starting with. So you have to either set up this proportion method, or if I do this in blue, if you want the correct method, if you don't want to do the proportion, would be to divide. You would have to do $18 divided by 8.82. And that would give you the same amount. Whoops, put my decimal in the wrong spot. 21.95. So you'd have to figure out 100 minus 18 to get the 82%, and then you'd be dividing to undo it, because to get the sales, you multiply by the percent. So you divide to undo it. But the method by dividing is not intuitive. It's a lot harder for people to remember that and remember, okay, this is a situation where I have to divide. That's why I teach the proportion method, because the proportion method, it doesn't matter whether it's one where you're finding the sales tax or you're finding the original price. It doesn't matter what you're looking for. The setup is the same. And so you don't have to remember, is this one where I multiply this? Is this one where I divide? Is this the one where I divide by the 100 minus, or do I have to do 100 plus? You don't have to worry about any of that because the setup works no matter what. Are there any questions? Okay. And then here's another one. This time we're looking for the percent. So during its first year, a gaming console sold for $425 in stores. This product was in such demand that it sold for $800 online. What percent markup does this represent? So I'm going to show with my proportion method, and then I'll show it the other method. So if we have the proportion method, the new price is $800. The original price was $425, so it's going to be 800 over 425. On the right side, it's always over 100, and we're looking for the percent markup, what's added. So we have 100 plus X. So we're looking for what percent was added on. So when I multiply my diagonals, I have 800 times 100. And then I have 425 times 100 plus x. And I have to put the 100 plus x in parentheses because that 425 is going to be multiplied by everything there. So on the left, I need to just multiply. And then on the right, I have to distribute. So I need to do 425 times 100. So that's 425, basically just add 2 zeros, plus, and then I multiply it by the x. So that's 425x. So now I need to solve for the x. I need to remove the 42,500 there. So I'm going to subtract that value from both sides. I'm going to take my calculator and make sure I have the right number of zeros. So this gives us 37,500 equals 425x. So now I need to divide both sides by 425 because I just want x. And then it says round to the nearest whole percent. So I got 88.2, so that rounds down to 88%. So that was an 88% markup. The alternate method is to take 800, divide it by 425, and multiply it by 100 to see what percent 800 is out of 425. Now when you do that, you get 188.24%. Now it's not a 100 and, oh, that's supposed to say an 8 there. It's not 188% markup, it's an 88% markup because you have to remember that you started at 100. So you'd have to subtract 100 there to figure out that it was an 88% markup from that point. Because that takes in the 100. It's 188% of the original, but really it was an 88% increase there. So if you use my method with the proportion, it's longer, but you don't have to remember to subtract 100% to get your answer for the percent markup. Are there any questions? Okay, this is my last sales markup, that sort of thing. The original price of an audio jukebox is $260. It is on sale for $220. What percent discount does this represent? So sale price, that's new price, is 220, so that goes on top of our fraction. And the original price is on the bottom, so that's 260. The right side is always over 100. And then it's discount, so we're always subtracting the percent. So we don't know the percent, so I'm subtracting x in this case. So it's very similar to example 7, but now it's a subtraction instead of addition. So I need to cross multiply, so I have 220 times 100. And then I multiply 260 times 100 minus x. So on the left, I simply multiply. And then on the right, I have to distribute. So I have 260 times 100, which adds 2 extra zeros. Then 260 times negative x, so that's minus 260x. So now I need to get rid of the 26,000 on the right because I don't want to have any numbers by itself. I mean, I want to have everything without an x on the left to get away from the x. So I'm going to subtract 26,000 from both sides. That gives me negative 4,000. That equals negative 260x. So I need to divide both sides by negative 260 so that I can have just x by itself. Okay, so this gives me a decimal, lots of decimals. Let's say we use two decimal places. So I got 15.384, so that's going to be 15.38%. So this was a 15.38% discount. That's how much you're saving. Now, if you want to do this without doing a proportion, what you would do is 220 divided by 260 times 100. And that gives you 84.62. Then you need to subtract that by 100 to figure out what the discount is, because that's how much you're paying after the discount. So if you subtract that from 100, that gives you your 15.38%. So you are paying 84.62% of the original price, which meant you saved 15.38%. So it's similar to example 7, where we had to subtract 100. In this case, it's the other way around. You're basically finding the difference from 100 to figure out how much was added or how much was subtracted. Any questions? Okay, so next, if I can get this to change slides, come on, there it goes. Simple interest. So simple interest involves percents. This is when you're charged interest on your original amount, but there's not interest on the interest you're accumulating each month. So the interest is only on the original, it's not accumulating each month, which is what happens with most things like loans, mortgages, credit card bills, all that sort of stuff. So this is not, most real life is not simple interest, but simple interest is an easy way to start getting introduced to interest and how percents work. So the formula is the amount of simple interest is equal to the principal, which is basically the amount you're borrowing or the amount you have, times your annual interest rate. Simple interest is always annually, so it's always per year. So you get interest once a year, which is different from most bank accounts and everything. And then you multiply that by how many years you're getting interest. So the equation is I equals PRT. In order to use this formula, the interest rate, the R, has to be written in decimal form. So you have to divide it by 100 in order to use it correctly in this formula. The other thing is this is only telling you how much interest you got. It does not tell you the total with the interest. So if you're wondering how much you have in a bank account, this will not tell you that. It just tells you how much interest you earned. You then have to add it back into what you started with to find the total amount. So example 9 here, how much interest will Roxanne have to pay if she borrows $2,000 for 2 years at a simple interest rate of 4%? So we're going to use our I equals PRT. So we're looking for the amount of interest. So we don't know I. The principal is how much she's borrowing, so that's $2,000. R is the interest rate. We have to convert that to a decimal by dividing that by 100. So 4% is 0.04. And then T is how many years? So that's 2 years. So all you have to do is plug in the formula, put this on your calculator, and we get $160. So she's paying $160 of simple interest if she's borrowing $2,000 at an interest rate 4% for 2 years. Here's one that's a little more complicated. Andrea borrowed some money for 2 years at 6% simple interest. She had to pay back a total of $3,640. How much did she originally borrow? So this $3,640, this is the original she borrowed plus the interest. So that's not just the interest, that's the original she borrowed plus the interest. So we need to replace the interest formula with what it's equal to, P times R times T, the principal plus the rate times time. And now we're going to plug in the numbers. So we have 3,640 equals P. We don't know how much she borrowed, so we don't know P. We know the interest rate, 6%, so we have to convert to a decimal, so that's 0.06. And then T is the time, so that is 2. So I have 3,640 equals P plus 0.06 times 2 is 0.12 P. So on the right side, these are like terms. I have P plus 0.12 P. That's 1 plus 0.12 P. So when I combine those, I get 1.12 P. So now we're going to divide both sides by 1.12 in order to figure out how much she originally borrowed. And that came to $3,250 was the amount of principal. So she originally borrowed $3,250. Are any questions? Okay, and now on to my last example. If $9,000 grows to $10,440 in 2 years, find the simple interest rate. So we are using I equals PRT, but 10,940, well, that's including the principal. So we need to figure out how much interest was. So we need to subtract the 9,000 to find the amount of interest that was added on. So that's 1,440 of interest. So now I can plug that into my formula, 1,440, it's a terrible 4, equals We know the principal. We started with $9,000. We don't know the interest rate, but we know the time, which is again 2 years. So I have 1,440. I can do 9,000 times 2, which is 18,000 R. And now I need to divide both sides by 18,000. So that can be 0.08 equals R. Now the R is always the decimal form, so you have to multiply by that by 100 to get the interest rate. So that is really 8% simple interest. Are there any questions? Okay, so that brings me to the end. That basically is 2.5 in a nutshell. I know that some of the problems probably look much more complicated than they need to be, but I'm using the same method for every problem, so that's a little more universal. So that works for some people. Some people prefer that method. So use whichever method works best for you. And of course, if you have any questions, you can email me, you can give me a call. You can also send me a message through Remind or Google Hangouts, whatever works best for you. So hopefully this was helpful for you. And if you have questions, you guys have any questions? You guys have been pretty quiet.
No questions here.
All right. So yeah, so all right, so that's all I've got for you guys. Glad that you guys are able to join me. Our next live session is just going to be our introduction. I believe that's 7 o'clock. Let me pull up my calendar. I know I sent a reminder about it, but I always have to remind myself. Yes, 7 o'clock on Wednesday. I have not yet figured out what I'm going to go over, for which section I'm going to do a live session for week 4 yet, but that is on. I will be figuring that out. So, all right. Thank you guys for joining me. I really appreciate it. So, I hope you guys have a great night.
Thank you, you too.
You're welcome. Bye.